All right. One of the next things I want to talk about are these. Well, there's going to be a lot of pictures today. Okay, so what's happening here?
Water is like being pushed, like since that's like the meandering.
Okay, so we have a lot of meanders. Okay, and what's going to happen?
It's like gonna get like it's gonna be pushed out.
Yeah, so okay, go back to what we said in the previous slide. If I'm depositing on the inside, so the deposition's here, what am I doing on the outside? Eroding. Okay, so when I come around this bend, I'm depositing here, but what am I doing on this side? Keep the river process working, eroding, 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 eroding. What's going to happen? Eventually, what's going to happen to that little tiny strip of land? It's going to be gone. The river actually will break through that, and then we get a whole new channel where the new water will flow through here. This, when that happens, when that actually gets squeezed off, is what we call an oxbow lake. Yes, ma'am.
I have two questions. Is that a picture or is it real?
That's real.
And then, yeah, it looks like a drawing.
No,
But
it's not.
and then like with lakes that have like a bunch of channels from far, like from up really high, is that what they look like?
What do you mean a lake that has lots of channels?
Like I don't know, like how all the channels are connected,
What
but
channel?
they're in like different spots, like on the lake.
Like channel lakes.
Yeah.
Yes.
There's like different channels. That's what it looks like from like behind.
All right, so we look at basically we get that meanders. They eventually cut through the rock. We get this thing called the Oxbow Lake, and we basically end up with this system right here. So you can see where we said this really tight meander that came through, and then the river simply cut through that cutoff. And we've got the new river channel. And over time, in this region right through here, we get more deposition that it takes place, and we basically block off the oxbow. And when that happens, there's no longer water to keep that channel filled, so what's going to happen with the water in the channel? It dries out, okay? It goes through a process we call eutrophication. And this is the same thing that's happened to Garrett over the last couple hundred years. Eutrophication is the point where we go from a very wet swamp or lake, and as more and more vegetation and sediment is poured into that area, the water is no longer taking up that space. It's being absorbed by the land, being absorbed by the vegetation, and it simply dries up over time. Most ponds and small lakes will, at one point in time, become forested again. And they will simply dry up and be replaced with vegetation. And we're actually seeing that right here in this image. You can see that starting to happen where the green's starting to take over and starting to feed into the channel. Oxbow lakes are common. They're common only with really, really big river systems. And they're basically going to happen in very very low or flat elevations. Okay, so you're not going to find oxbow lakes and lots of meanders in a steep slope. So it's got to be a nice level slope, very gentle. If you ever look at a road map in the United States, you can actually watch the Mississippi River, there are thousands of oxbow lakes that follow the river's edge, all the way down. Eutrophication. It's basically where you have a wetland that is slowly becoming dried up, and because the vegetation is coming in, and it basically just becomes filled with shrubs and trees and Alright, so we talked about the fact that streams change over time. I would say that, and they change very rapidly. Alright, so we're going to look at this image here. It's how much a stream changes from 1935 to 1990. That's a difference of only 55 years. So here's the original channel in 1935. What do you guys notice? What's going to happen right through here? Exactly, right? We got the tight meander. The river channel will slowly eat over that over time. So let's see then what happens in 1958. Just in a matter of 23 years. So what happened to our little loop out here? Now that's just in a matter of 23 years. A very, very rapid amount of time when we think about geologic. And you can also see some other places where it has created oxbow lakes, such as this little area right through here. It's cut off another one. And yet we have other meanders that take place. So let's go from now, from 1958 to 1973. Now in that 20-year time, don't really get a lot of changes that take place. We do somewhat cut off this area right here, but almost the same channel. And when we get to 1990, we have a little bit more changes take place. And look at this area right here in the middle. So that new river channel really completely cut off large areas of that old river channel. And that was just in 17 years. So we back this up and we actually go back to 1935 and compare it to 1990. So that's how much change can take place in the river's channel in just 55 years. Alright, so before we close off our notes, what questions do you guys have in terms of how things work? Remember, basically test questions, explain to me how an oxbow lake is formed, explain to me how point bar depositions are formed. Which of those do you want me to go in a little bit more detail before we close this off? Alright, so let's use this slide here. I've got the greatest here. Alright, okay, think about the record spinning, right? We talked about this before. The outside has a farther distance to travel than the inside, right? So as I start spinning this thing around, my outside has a farther distance to travel in the same amount of time. Therefore, it's moving faster than the inside. Does that make sense? So, one that's moving faster has a higher carrying capacity than the one that's moving slower, correct? Okay, so as I move around my meander, I slow down on the inside. So we're slowing here. And then I'm a lot faster on the outside. So since I'm slowing down on the inside, I lose my carrying capacity, and therefore my sediments fall out of suspension. On the inside, you have to deposit on the inside, and we erode on the outside. And you'll see in a lot of places, people start putting up the large rocks, the jagged rocks, try and prevent the water from eroding on that outside of the land. Here's the problem. If it's not going to erode here, it's going to erode somewhere. Remember, the river is trying to reach equilibrium. So while it's depositing on this side of the river, it needs to find something to balance out that loss of sediment. So at some point, it's going to erode. So you can put all the rocks there you want, and yes, you say that that particular location, but later on down the river, it's going to erode even more. So keep that in mind. And right here is another example where we have this down cut on the outside of the curve and deposition on the inside. All right, anybody else?